In this ladder friction problem, a uniform ladder 6 meter long weighing 300 Newton is resting against a wall with which it makes 30 degree. A man weighing 750 Newton climbs up the ladder, and at what position along the ladder from the bottom does the ladder slip? Coefficient of friction at all the contact surfaces is equal to 0.2. That is a question. So we need to find the distance along the ladder at which the ladder will slip. That means we have to find the distance from bottom along the ladder where the man is, and at that point the ladder will be slipping. So to solve this, we have to draw a figure. Draw the ladder. I will be drawing the free body diagram. So this is the ladder. This is the vertical wall, and this is the angle 30 degree. It was given in the question. And on the wall we have RW, as the wall is not smooth. We have FW, this is equal to mu into RW, because mu is same for all the contact surfaces. And we have RF, normal reaction at the floor, and FF equal to mu into RF, that is limiting friction at a point A. Then weight of the ladder acting vertically downwards. Its weight is given as 300 Newton. As the ladder is told to be uniform ladder, its weight is acting through the center of gravity. So the total length of the ladder is 6 meters. So this will be 3 meter. Okay. I will draw this 3 meter. That is the center of gravity of the ladder from the bottom end, and from the top end also it will be same. Now a man is climbing up the ladder whose weight is 750 Newton, and we assume that at this position along the ladder, along the length of the ladder slips. That means when the man is at this position, the ladder will slip, or the ladder will be just about to slip. That means the ladder will be in limiting equilibrium. Ladder will be in limiting equilibrium. So these are the forces acting on the ladder. So first one is the weight of the ladder at the center, 300 Newton downwards. Next is the weight of the man who is climbing up the ladder, 750 Newton vertically downwards at X from the bottom along the ladder. And the normal reaction at the floor, RF, and corresponding limiting friction at the floor, RFF equal to mu into RF, where mu is equal to 0.2. And on the other point, so this is point A, and this is point B. And at the wall, the two forces acting on the ladder are the normal reaction Rw and the corresponding friction, limiting friction at the wall Fw equal to mu into Rw. So these are the forces acting on the ladder. Now we need to find the distance x. How to find out distance x? For this, we will consider the limiting equilibrium of the ladder and apply the equilibrium conditions. So first of all, we will apply the condition sigma h equal to 0. That means horizontal forces acting on the floor, the net horizontal force equal to 0, or the ladder is in equilibrium. It is not moving in the horizontal direction. Therefore, what are the horizontal forces? Rw in the from left to right taken as positive, Rw, then the other one is mu into Rf. It is equal to 0.2 into Rf. Rw is equal to 0.2 into Rf. Then let this be equation number 1. For sigma v equal to 0, next we can apply sigma v is equal to 0. That is, forces in the vertical direction equal to 0. Net force in the vertical direction equal to 0. That will give, which are the vertical forces? Rf is in the upward direction taken as positive. Rf, Fw, that is mu into Rw, then vertical forces are 300 and 750. It is minus vertically downwards equal to 0. So 1, 2, 3 and 4. 4 forces are there. Rf and mu Rw are acting vertically upwards taken as positive. 300 and 750 are acting downwards and taken as negative. So this will give Rf plus 0.2 Rw equal to 300 plus 750, 10, 50, and this is equation number 2. So Rw is equal to 0.2 Rf, or you can write from equation number 1, Rf is equal to Rw by 0.2. Rw by 0.2. That is 5 Rw. Therefore, equation number 2 can be written as 5 Rw plus 0.2 Rw equal to 1050, or we will get, that is Rw equal to 201.92 Newton. That is Rw. Rw is the reaction at point B from the wall, and its value is 201.92 Newton. Now consider sigma m A equal to 0. That is sum of all the moments about point A equal to 0. A is the bottom point. So we have to find out the moments of all the forces about point A. So these two forces, that is Rf and Ff, will not make any moment. only forces which are making moment will be 750, 300, RW and FW. Okay, so the distances will be is the ladder. So it's 30 degree. This is total length is 6 meters. Up to center it is 3 meters. We have another x. So this angle will be 60 degree. Okay, therefore so this distance will be 6 sine 30, and this distance will be x sine 30, and this distance will be 3 sine 30. Okay, now we will find out the moments. So this will not create any moment and this will not create any moment. So first force which is creating moment about point A is say 750, and the 750 Newton force is creating a moment of 750. We are putting it like this and applying the force like this. It will be in the anti-clockwise direction. So minus 750 into the perpendicular distance between the line of action of the force and the point, that is this distance. That means x sine 30. X sine 30 minus, because it is anti-clockwise, next is 300 at 3 sine 30 minus, that also is making anti-clockwise moment, minus 300 into 3 sine 30, then which is the other force, RW. RW, or we will take the vertical force as a FW, that is mu into RW. Mu is 0.2 into RW. That will be making a clockwise moment, because it will be like this. If you apply the force, it will be creating a clockwise moment. So plus mu into RW, that is 0.2 into 201.92, that is our value of RW. Next, and the last force which is creating moment is RW, which will also be making a clockwise moment like this. So it will also be plus RW. RW is 201.92 into the perpendicular distance between the point and line of action will be this vertical distance. So that will be this distance will be 6 sine 60. This should be equal to 0 because 6, its sine component, it is vertical component, will be 6 sine 60. Okay. So when you solve this, here is only one unknown. When you solve this, you will get x equal to 1.92 meters. That is, at 1.92 meters from point A along the ladder, when the man climbs at this point or reach at this point, the ladder will just slip. That means the ladder will be in limiting equilibrium.